Alright guys, I haven't made a video in a while, but yeah, I've gotten a good amount of stuff done. Uh FRC is over, so it's just me posting videos now. I thought of this mechanism in a dream and I made it. Took 2 days. Looks a little weird, but it's a rack and pinion drive, high speed. So as you see there, it's in a gear set. So the small blue gear gets driven by this smaller ratio orange gear, which is long, and then that drives it's on one shaft, so that comes all the way down to here, which is large pulley, which then goes to this pulley stager with a rubber band, and then that drops down to a smaller pulley, which then gets driven by the smallest pulley. And for some added back torque, right? Because if you just have one driving, it's going to be the one experiencing all of the torque, and this one's just a caster. They're coupled with rubber bands, and I did some tests, and if it were a 200% ratio, if this is doing 100% of the power, this is doing around 200% of the... No, not 200, around 40%, or 50%. So it's around 150%, right? Because obviously the losses in the rubber band. Honestly, running the mechanism through, it's probably around 70, 60, 70, 67, anyways. So yeah, let me dive a little deeper. Actually, I have this thing plugged in. Yeah, sorry about that. I had it plugged in. I didn't want to blow it up like the last time. Just the motor controller here. It's using a Firma 8-amp ESC. These things are sold out. And my other one broke, and I was meant to make a blade-type tracked vehicle. But the other one blew up, so... Yeah, it didn't even blow up. It just stopped working entirely. It makes no sense. So, oh well. So I decided to use the ESC for this purpose, right? So after driving down, it's doing this. It's just a little center caster. It has this wheel tensioner and these two top rollers to stop it from going up and down. The thing is, though, it does have this slight issue where you look here. If I push on it slightly, it decouples. That's what the rubber band is helpful for. So if it were to decouple from one, it's getting driven by this one. There's no chance that it decouples from both, because then you would snap this thing in half. Not the mechanism, this. You would snap this in half. So, it's helpful. It's definitely helpful. This shaft needs to be trimmed. This is what I used to use testing for a drill. Because this one has a higher resistance than this, if you were to spin this to drive this, there's more resistance in this than, because, well, it's obviously coupled. But if you were to uncouple all of this, it still has more resistance. So that's why I'm driving it from this side and not this side. Don't mind that. Those are two fucked up holes for the tensioner placement. That shows that I really just scrapped this thing together. But it's a hard thought of mechanism, as you see. Time for the demonstration. So as you see here, I have no microcontroller. What's this used for? It's going to be on a robot that has a tracking camera that I coded up, that I also bought. It's going to have a limit switch up in the front, and an arm is going to be attached to this section. That's why you don't see any of the thickened backer. It's just a rack and pinion. Sorry, rack. And there's going to be one on the front to senses when it's at full travel. So here's the speed of it. I'm using a RC remote. That won't be used for the final iteration. What's going on? Sorry about that. This receiver has a grounding issue, I think. So you have to re-plug it in and plug it back in so the ESC initializes properly. So that's how slow it is. So this is an arm, essentially. So this long section here, if I pull it back in, what it can do, if you see it from here, what I designed it to do, right? It's able to fully suck itself back into the frame. And as you see there, it's tucked in nicely within the frame. And what's going to go on here is essentially a claw that's going to be like this. And when the robot sees a desired object, it's going to shoot the arm out. Like that. It came off the rack. if I push this back in, and as you see there, so better if it's going to grab and then pull the object back in. Yeah, there's no limit switches or limits, so it's just able to do. Because this ESC was designed for crawlers, as you see, it's faster in the pulling direction, and because of how these ESCs work, there is zero way to reverse it. Zero way. That is why they cut these things off. There's no way to reverse the ESC. You have to reverse it in the rail, but then one way is going to be faster than the other. And these things don't have adequate torque for crawlers. They have adequate torque for robotics, but Spectrum isn't a robotics company, aren't they? These are very good for tiny robots, but they were not good for hobbyists who, want a fast little RC car. But if you want a cool, fast, robotic actuator or robot that's able to drive around quickly with adequate torque control, you're able to do that. But, well, they took these things off the market. You can find things like that, but they're really expensive. When this thing came out, it was dirt cheap. All the other companies that do stuff like this, like Fui Tech and all that, yeah. That is, like, the reason why I did the whole FOC actuator project is because I wanted to replicate a small-scale version of this that I'm able to personally do. And it worked, definitely. It did work, but I definitely overtook the project and ended up turning it into an actuator, but my whole issue was turning it into a ESC, essentially. But I realized why I had so many issues, and I'm able to fix them now, so, yeah. So, essentially, this thing is going to be able to pivot on a servo, and I don't need to tilt it up and down, because this whole mechanism is meant to be on a robot that sits on the flat, like, floor, and it's driving. Oh, see an object, align to the object, and then pull the object in. That's essentially it. It's running off 2S at the moment. 1S doesn't have adequate torque and speed, so. Here's a little close-up of the drive. And if it ever encounters something that its torque can't, it's hard to hold the camera and do this at the same time. Here you go. If it can't do it, right? So I drive it forward. As you see, the mechanism simply slips. That's it. If it encounters something that it can't do, and if the code were to break and it overdoes one of the limit switches, you don't break a gear or shred a gear. All you do is break a rubber band. That's why I did this. The issue that I had with these motor was originally put on was the fact that when you make a custom gearbox out of like a toy or something, because, they're where you get the best gearboxes for vehicles of a high-speed driving kind. But what happened is that if a gear were to break, if that toy were to be something you found and took apart and essentially gutted, if they don't make it anymore, your gears are gone and the thing is shelved, right? But what I realized is that if you use these pulleys that you can buy off AliExpress or Amazon for like $11 and a big pack of like gears and stuff, that's why I have all these gears and pulleys, all you have to do is replace the rubber bands and you're good. You don't have to rely on the fact that, oh yeah, I hope this business stays in, business, so I'm able to buy those gears. With this mechanism, all you have to do is replace the rubber bands, and you're good. And they make rubber bands in various sizes, and for the next couple hundred years, they're going to be making rubber bands. That's the thing. In the next couple hundred years, they're not going to make this rack and pinion, but that's not the thing that's going to break because it has a lot of fail safes in place that make sure it's not going to break. The things that are under the most amount of, stress are this mechanism driving this. So that's why I use rubber bands for this, right? So instead of doing like a capstan drive where you can simply attach a piece of string here, and then have like a pulley that has the string wrapped around. So as you rotate the pulley, it rides and unravels at an equal tension to drive the mechanism back and forth. I feel like that's a little silly for this purpose. So yeah, that's why I did this. Me thinking of this in a dream, it wasn't a joke. I had a dream about it, and I was like, ooh, that would be a cool robot. So I start to build it. It's mainly just procrastination for one of my other projects. And screw it, I'll show it here. Yeah, it's a little scrappy, but it's a dual arm manipulator robot. I started this before all these companies started coming out with AI learning robots. Because at the moment, I did not see any teleoperated dual arm robots online. I thought I'd just be the first one, not the first one, obviously, but the first one to drop a new vid, right? Then as soon as I start getting into the knit and grip of this project to here, everyone's doing it. So, yeah. It pisses me off. This thing doesn't have AI. It's meant to have a full human operator. It has a high-power unit with cooling. It has an antenna here for long-range jobs. It has a distribution board, and it's limited to 6 volts because I asked chat, and according to it, anything over, I might blow it up because obviously as you raise the voltage, the amps that these servos pull ends up going higher. And I looked at the data sheets, I'm limiting these servos, but they have adequate torque for my purposes because, whatever it's capable of lifting is limited by the wrists, and as you see here, I'm clearly limited by space. So as you see here, so we have a full actuated wrist with, I did a lot of thought, and, so as you see here, it has this, the up and down of your arm, and the left. So it's essentially this part of your arm here, minus all of this, right? So it's just from your elbow out, all of those controls. So what I'm going to do is I'm going to have two, essentially of those 9-gram Metal Gear servos, right? And stay with me here. Because of how potentiometers work, hold on. Okay, I'm back. This is the human-operated rig here. It's close to an exact replica. It's slightly downsized, so all the distances. So as you see here, I'm able to fully articulate it and move around in 3D space, both arms, and it's run off an ESP32. And because of, if you know ball with ESP32s, there are two separate, essentially, two separate drive units of, let's just, example here. Two separate drive units of the vehicle. There's essentially 8 and 8. But you're only able to do one at a time on each segment. So, if you want to read potentiometers on number 1, you can read all 8. Fine. There's nothing else on it, so it's using it to its full potential. But on the other side, it has Wi-Fi and read. So you're only able to either read or use Wi-Fi. If you use Wi-Fi, you cannot read, and if you read, you cannot use Wi-Fi. So what I did here is I'm just off-putting serial, essentially, because it's in the same read-write function for either analog to digital or, serial, because it's all in one. So what I'm doing is I'm off-sourcing that Wi-Fi capability to another ESP32. And at the moment, this is having a power issue because the buck converter on this is not able to provide enough power for this to run Wi-Fi. It constantly boot loops, and when I power this off its own battery and this off its own battery, or just plug it in, it works. So I'm going to do a whole wiring scheme with a buck converter to, use a drill battery and then power this so I have hours of operation. And that robot is powered off of a drill battery. So it's also going to get hours of operation. So, as you see, back to what I was saying, because the servos are 200 and, no, sorry, because these potentiometers, I did spoil it, but you get what I'm saying. Because these potentiometers move around 270 degrees of full rotation and reading all these, I had an issue to where I want, whenever I make a movement on this, almost like a space mouse, to be very close to accurate on the robot. Not as if you're just moving a joystick and hoping it follows, right? I want it to be almost one to one. But with 180-degree servos, which are the norm of servos, you can't really do that. I mean, you can, but that will require essentially a homing sequence for each individual potentiometer because, well, these things don't come out of the factory exactly exact. But if you use all-around code like I have, if you plug in a potentiometer from 0 to its max read, which is always around 270 degrees because that's how they build the little notch in the... If I show you here, that little notch, there's a little limiter in the inside, so when you make a full rotation, it locks out at 270 degrees. I use 270-degree servos. So back to the 9-gram servos, as I say, sure, they might have adequate torque, but I used them in the project before, they're pretty good. And because it's rare, you're able to get those in 270-degree variants. If you're trying to take up a project like this, you cannot get them off Amazon. Amazon does not sell them. I mean, they probably do in the future, but at the moment, you're not able to get any of them for a good price. And this project has already taken long enough. As I said, people innovated with AI. I innovated with AI. And I saw a joke about ChatGPT. I made an AI camera for FRC that's able to track able text, but it's $70. Yeah, that's a little thing I did during FRC. Anyways, yeah. So that's what I did. And now it simply just couples the full rotation to the 270-degree servo, and whatever's max is there is put to that range. But no, this range is dropped from around 0 to 4,000 because it's using voltages instead of, actual measurements to 0 to 270 degrees. And because this moves 270 degrees, it works with the servo adequately. It serves a bit more and a bit less, but it makes the control way more intuitive than just using a joystick. I was originally deterred from this because of, look at the thing, and I use super glue to mount these, right? I don't have a 3D printer. All of this is custom, cut, measured, and cut apart to have high strength pieces. But because if you know ball, cyanoacrylate glue off gases as it dries, right? Because there's an exothermic reaction, so it's losing some material during the reaction, mainly the solvent, I think, and that ends up essentially leaving a white filmy residue on it. And you know that these things use a wiper on a carbon track to vary the voltage that it reads. If you have anything on that carbon track, it's going to off-do your voltage or create an alternating pulsing voltage in that area with it where it's off-gassed on. And if you translate that to motion on the servo, 1 second it's doing fine, you move it past that area, and because it's coupled, your servo starts jittering. You're not jittering, but the reading gets messed up from the off-gas. So either you use Model Maker cyanoacrylate glue, which is hard to find in Canada because, there aren't many hobby shops up in Toronto. But, yeah. So I had to do a whole method of keeping airflow on these things so whenever off-gas gets blown away, and if these things were to break, I accidentally snapped these off of the mechanism a little bit. I had to glue them back on, and I had to plug up every hole with glue. I left that hole in case I need to clean it. But it's either it off gases so much to where you literally cannot clean it and it's always going to be glitched out, or, yeah. Because I'm using these for essentially high precision tasks, I'm coupling essentially the full movement of this to the full movement of the servo. Whatever jitter is there is going to translate to the servo. If I were to use 180-degree servos, this problem will go away. I use this on a I use potentiometers on a robot that I made for FRC last year, and it used a microbit. And because those 180-degree servos, the movement wasn't 1-to-1. So whatever jitter it saw as I junked superglue on the thing, it doesn't matter because it's not to the full range. It's doing math to drop the range. It's essentially setting points in between as a ratio, and then that essentially equivalizes what movement does what. So, yeah. It's essentially what I've been doing. That's the chassis for the robot. Anything else I've made? Essentially, that's it. Yeah. Alright, guys. That's all I have for you today. This video was a tad long. My channel is too small for me to making fucking 22-minute videos. But I have to make sure that I log all of my projects. Because it's starting to look like I'm doing this shit for no reason if I have no proof that I am doing it. I am spending my time making robots. People simply think I go home and go straight to sleep. But no, I go home, I go straight to sleep, and then I wake up to make robots. I've been making robots my entire life, and this is what I do. So, yeah. Yeah, anyways, actually, this video is too long, I'm not going to talk about it. I'm going to make a second video on the AI camera, how you could make it, and how your FRC team can benefit from a $70 AI camera that's either able to track objects or do full April tag tracking with multi-tag localization. That requires some math. I did not do that math, but I did the simpler, just, Limelight 3A, left, right tracking, right? With distance measurements using the square cube law. And that worked so well. Oh my god. It worked so well. Dude. Man, I'm just gonna give you a sneak peek of the camera, the board. I blew it up. I'm ordering a new board because I blew it up. That was due to my error. If you were to use it for FRC, it would never blow up. It never gets to that stage. Screw it, this video's already long. So, I did 3 months of research just to look at a board that would do AI tracking, right? Because start a year, I said I want to move up from little robots, essentially, and I want to move big. So, I did research. I started with the K110 processor from, I think, Kendrite Systems. Yeah, it was the Husky Lens version 1 that used the K10. It wasn't that good. I made an entire gimbal mechanism. This is the remnants of it. It housed a FOC controller, a motor that I obviously designed. I have videos on that, dude. And look around here, the whole platform. It had a whole rotating mechanism. Just for the thing to not work, because what the K110 was good for was, essentially line tracking. Everything else it could do, but not so good. If I were to buy a bare bones version, I definitely would have gotten more processing power out of it because, the Husky Lens, they add bloatware to it, essentially. But that bloatware is useful bloatware. It's meant for the user experience to be more usable for average users. But I am not your average user. I want to push that processor to its limit. And at the time, I did not have enough information, so I sent it back. It was a very good product. If you plan on doing simple AI tracking for stuff, like if you want to make a line tracking robot, if you want it to be easy, I suggest you do it. Just so you know, the library that they put, you have to edit the library to work with ESP32. It only works with Arduino, but I made a library. I cannot post it because I don't know if that's illegal. I used chat to do it, but it took some work. It was equal effort for me and chat. It's just me, so, yeah. So, yeah, you need to make your own library for it. It's just editing the existing library file because it's a file and they actually haven't made it with Arduino. So, you're able to just edit the file and then upload that new file as your library, and it would work with ESP32. And it has full read and write, so you're able to actuate settings from this end, I think. But the camera tells you everything that it's doing. If it's lost an object, if it sees an object, what settings it's at, over serial. It's beautiful. Very nice, very good. But back to the FRC cam. So, I did some more research after that for 3 months, and I discovered the K230 processor. It runs at around 1.6 gigahertz or 1.5. It's varying depending on the seller. And the bandwidth for RAM is from either 100 and something megabytes, 128 megabytes of DDR3 to 2 gigabytes of DDR4 RAM. Beautiful! I was like, this is great. I pimped out. I got the 2 gig version. Oh yeah. And I was looking around. First, I stumbled upon another company, and I realized that is essentially like the K110 Husky lens. And I was like, you know what? I want something that's cheaper and a little more bare bones, right? I want something that I'm able to work with and get in with that also has good, user reception. Not user reception, documentation. I don't care about user reception. These boards are purely custom. Made by 01 Studio, lovely company. No issues with the board, 0. It's just, if you want to, have a look at some of the other programs, it's all in Chinese, so I had to, translate it on the website. But it's not hard. This thing is essentially a dev board. They have different versions. They also have, essentially, a compute module of the board, but that one only comes with 1 gig, and it's cheaper, but, I want the 2 gigabyte version at a small size. So, this one has the processor, the 2 gig DDR4 module. It has serial output. It has USB. That's mainly just for the Ethernet. It's not really USB. It has a actuation key on a different, that's just a reset. Even has a Wi-Fi module. For my purposes, I will never use the Wi-Fi module, so if they're able to just make a board with simply just this, y'all, you can leave that, leave the key, and then, some of these, yeah. If they were to make these solder points, I would also like that. I do not like the fact that these are just pins. Yeah, it uses USB 2.0. It has an SD card, a boot button. It also has a second camera port and a display port for a 2.4-inch LCD. It's wonderful. So essentially, I looked at the programs and I realized that it's using a stripped down version of OpenCV, and then they edited it, for, this board. Because, different pinout and all that from, the company who made the processor's pinout from, so I simply edited that, made a lot of speed changes, and editing changes, and I had a full AI tracking, not AI, actually it is AI tracking computer vision camera that's able to track April tags. It's crazy. And it only costs $80. $80 for a full AI track? Dude, a Limelight 4 costs $300. And it does the same thing. But it also is better. But this thing does it just as good because it's able to run full AprilTag tracking at around 20 FPS. That thing gets around 100 and something FPS, but it's not a slideshow. 20, 30 FPS is excellent to look at. And with how AI works, if you're looking at the system, looking through the camera's eyes, if you're able to easily deter what objects are, the AI is easily able to deter what objects are. That's probably a bad explanation, and any AI expert will go, oh, shut up, dude. So take it with a grain of salt. But I use that analogy, and this thing works excellent. You're able to simply hook up an USB port. The RoboRio on an FRC robot uses USB, right? It's 900 milliamps, this requires 2 amps, but, it's not pulling that much power, essentially. You just use the USB plug it into your RoboRio. I had a friend made the program that simply interprets what this spits out over serial to the RoboRio, and essentially, reading that data, you're able to deter where their AprilTag is and get the robot to center to that AprilTag. All that for $70? And the thing is, you're also able to do full localization. I was only limiting the data that was being spit out of this, but the RoboRio is able to also interpret all of the data that it receives from that AprilTag. I was only limiting it because I wasn't using it for that task. It would have taken too long. It's able to use that data to get full field localization to the robot. Obviously using, X and Y transforms and all that. I ain't getting to the nit and grit, but I also know how to do it. It just would have taken too long because, it's just me working on the camera because I decided to. It's not like a forced thing. I decided to do this and it took me too long. This robot also took me too long, but you get the point. Dude, wonderful, wonderful. They're on AliExpress. I think it's a limited run, but they still have a bunch of the boards in. Guys, go get this, man. Go get it. If you know what you're doing. If not, dude, get the Husky Lens 2. It's using the K230. But the user experience, if you don't know what you're doing, is way simpler. So I suggest you use that. But if you want to push, if you want a lightweight, cheap system that works and is fast and is rugged, yeah, I suggest you do it. And if you plan on using this thing, do not, you can communicate to other devices using this, but the wire that they give is super thin and flimsy, and for rugged purposes of a moving gimbal, those wires are bound to snap. And it's not on their end. These pins are small, and they aren't the main purpose of this device, so you cannot wrong them, and it's not on them. It is on me. Use the USB port. Use something like the ESP32S3 with full USB and get it to work through that. I am ordering all the stuff for that, so you will see this in the future. And this processor gets a little spicy when running AI tasks, so I suggest you have a fan on it. Just a small little fan at a low RPM, it'll work. This thing can shoot up to 80, 70 degrees. I mean, it's not enough to melt the solder, but it is enough to, hurt your finger if you touch it for too long. And yeah. If you want to do AI tasks, right, I suggest you get the 2 gig model. 1 gigabyte is plenty, but if you don't want to be limited, get 2 gigabytes. Trust me, it is worth the extra $10 bump from around $60 to $70 or, 80, $70 to $80. It's really worth the price. If they release a 2 gigabyte version of the compute module, get it. Get that. It's obviously going to be cheaper. Get that, obviously. And, yeah, this was a great, excellent board to work with. They have lots of example codes, so deterring, and they also have good explanations, so reading that and understanding, that is why this project worked pretty quickly for me and I started to understand it and, understood the programming. I did not program it. I did. What am I talking about? I am sleepy. It is like 8 in the night. Yes, I did program it, and it took 3 months of researching and looking at codes for this to understand how it worked. And then I also helped use ChatGPT to help me because, I don't know how to code. I could sit there and understand it, but when it comes to typing it out, yeah. So what I would do is I would essentially type out entire essays and documents, essentially copy and pasting documents from the no, sorry, not documents. Copy and pasting the code from there and then essentially giving a whole essay document on how this works, why this works, what I need from it, and to not make shit up, because if ChatGPT starts making shit up, you're screwed. So I essentially 3 months of research, like documents and documents of just reading, writing, understanding, just for it to go smoothly. You cannot jump into this project and start chatting stuff up with no knowledge and hoping ChatGPT knows. You have to know. It's essentially like you're a teacher. You have a super smart student, but they also don't know the subject. You teach that super smart student the subject, and because they're smart in this area and not smart in this area, you use your intelligence to be smart in that other area. That's how this works. That's how you prompt engineer code. You essentially have to be the engineer, and ChatGPT just has to edit code based on your whim. It cannot be using its ideas. You have to use your ideas. For electrical stuff like this, and that, do your research. Do not listen to chat. But then, once you've inputted your data, then it combines its data with your understanding to create a better result. That's how it works, dude. You cannot just go, oh, chat, do all this for me and expect it to be right. And then you sit there in a constant loop of misunderstandings and it doesn't work. You leave the project alone. You have to do your research. That's how that stuff works. Over the summer, I'm gonna try to see if I'm able to write code myself and eventually get it to where I don't ever have to use chat ever again. Just kidding. That's not gonna happen. But I want to be able to at least start typing. The reason why I don't type out code myself and just do months of research is because I'm a bad typer. I type with two individual fingers one at a time. And trust me, writing code is not like writing an essay. You need to be fast at it. So, yeah. It is what it is. It is what it is. I can't even type documents out, dude. It's bad. So, yeah, I need to also get my typing up, but it's weird. I'm able to do all this stuff, do all this research, but when it comes to actually applying it with my fingers through text, I cannot do it. It's strange, but, all I have to do is just become a better typer, and hey, I'm an all-around engineer, dude. Yeah, hold on. Is there anything else? Sweet, it's like 40 minutes. Hey, if people watch this, good, kudos to you, man. Lovely. My main computer that I end up doing all my stuff on, the keyboard broke, so, yeah, that's gonna be a sad, very, very sad. I'll use a Chromebook, essentially, to write out the code, and then I will use everything else for it. And then I'll simply transfer that code up to a document, edit, access the document through that, Control C, Control V, but I will doing all my working, typing, editing, and stuff. Like, okay, I know how to edit code. Well, let's not say I don't know how to code. I know how to edit code. Believe me, I'm able to edit code for my purposes and add a bit of stuff, but I cannot fully code, right? So ChatGPT makes up for that lapse in judgment. But it's not going over here saying, oh, you should do this with your code. It sometimes is helpful, but it's a very low chance. You gotta know what you're doing. You cannot let ChatGPT full ride the project, dude. You gotta be the engineer. It has to be the apprentice. It's apprentice that doesn't learn. So, yeah. other than that, yeah, that's it, dude. Goodbye, guys. This video is 40 minutes long. If you watch it, that's lovely. Goodbye.